we'll continue one series for 10-year solution, and all the question that I have taken here. The question is given from Calcutta University Mathematics Honors question paper. And this question is basically previous year question paper. So I'll start from question number 1. Question 1, and that has been asked in the year of honors 97. So what is the question? The question is, let S be the set of all 2 cross 2 real symmetric matrices A, B, C, D with AD minus BC. That means determinant is non-zero. AD minus BC non-zero, and R star with the set of all non-zero real number, with the set of all non-zero real numbers. Now show that the mapping, what is the question? Show that the mapping F is to R star defined as F of ABCD, that is equals to AD minus BC. This map is surjective, but not injective. Now the thing is how to solve this question. So what is the definition of injective map? That we first need to recall some basic facts. So recall some basic facts. What are the facts? A function if A to B is called injective. A function if A to B is called injective if and only if f of x equals to f of y. That implies x equals to y for all xy belongs to A. Or if and only if x not equals to y, that implies fx not equals to fy for all xy belongs to A. And recall 2, this is recall 1, and recall 2, f is a function if A to B is called surjective, if, or you can say onto map, if for all B belongs to B, there exists A belongs to A, such that f of A equals to B. So this is the definition of surjectiveness. Now we'll come to the question paper. So how to solve this kind of question? What is exactly given? So it is given that S is basically set of all 2 cross 2 real symmetric matrices A, B, C, D, all are 2 cross 2 real symmetric matrices that belongs to M to R, and where A is symmetric. So symmetric means A transpose equals to A and determinant of A is non-zero. So AD minus BC is non-zero. So this is the set S, and R star set of all non-zero real number, that means R minus 0. So this is basically set of all non-zero real numbers. And we have given the map, and the map, it is given that the map F S to R star is defined by F of A, B, C, D. This is equals to AD minus BC. So that means F of A, this is 2 cross 2, that is basically the determinant of A. So we have given the determinant map. So now we have to check this map is surjective, but it is not injective. So how to check this map is surjective? So this is the definition of surjectiveness. For all B belongs to B, there exists A belongs to A such that F equals to B. So here, just to think about the set S here and R star. So that means R minus 0, and here all symmetry matrices. So let we have taken an element X belongs to R star. So this is basically our codomain. And we have choose a matrices A. A is basically in that form X0, 0, 1. For X is non-zero real number. So obviously this must be belongs to S. Why? Since A equals to X0, 0, 1, this is a symmetric matrices. This is a symmetric matrix. And AD minus BC, that means determinant of A, this is X into 1 minus 0 into 0. That means X, and X belongs to R star. So this is non-zero as X belongs to R star. So it is symmetric matrices with determinant of A non-zero. So that means A belongs to S. Now we have this F of A, that means F of X0, 0, 1. That will be the determinant of A. So that will be X into 1 minus 0 into 0. So this is basically X. So that means A equals to X0, 0, 1. This is a pre-image of X. So since X is arbitrary, since X belongs to R star is arbitrary, so for all X belongs to R star codomain, there exists a matrix A of the form X0, 0, 1 such that F of A, this is equals to X. And hence we conclude F is to R star, this map is surjective. So surjectiveness is done. So what we proved? For any X belongs to R star, that exists X0, 0, 1, that matrix. So obviously it is a surjective map. Now we come to F is not injective. How we will show F is not injective? So that means we must show two elements in S, and the map of these two elements will be the same. That way we can show it is not surjective. So for the second part, we have taken two element F equals to 2, 0, 0, 1. And this is a symmetric matrix, determinant non-zero, so it belongs to S. We have taken another matrix B. This is that you can consider as 1, 2, 1, 2, 0, 0. This is also a symmetric matrix belongs to S. So then clearly A not equals to B. A not equals to B in S. So the matrix is here 2, 0, 0, 1, and here the matrix is 1, 0, 0, 2. Now what we have seen, but if A, now if A, what is if A? So that means f of 2001, and the map is AD minus BC. So determinant AD minus BC. So 2 into 1 minus 0 into 0, this will be 2. And what is FB? FB means f of 1200, that will be 1 into 2 minus 0 into again 2. So therefore A not equals to B, but f of A equals to f of B, and both are basically 2. So two distinct element, the image of two distinct element in S have the same image, this is 2. So thus F is basically S to R star. This map is not injective. So what we proved? We proved F S to R star is surjective map, surjective but not injective. So now we'll come to next important question. So next question is, that question is asked in Calcutta University, and it is honors 2000. What was the question? Let f n plus to n plus be the mapping given by f of x equals to 2x. What is n plus? Where n plus, this is basically set of all positive integers, is the set of all positive integers. Okay, that means it is basically set of all natural number. So what we have to show that f is injective but not surjective. Okay, so now we'll come to the solution. What is n plus here? N plus represent basically set of all positive integers. So what exactly mean by the set of all positive integers? 1, 2, 3, 4 and so on. And it has been given if n plus to n plus is given by f of x equals to 2x for all x belongs to n plus. This is given. So that means this is your n plus, again this is n plus. So here 1, 2, 3, 4, 5 and so on. That is also 1, 2, 3, 4, 5 and so on. So now what is the map? Fx equals to 2x. So 1 goes to 2, 2 goes to 4, 3 goes to 6. It is containing in that way. So just from this mapping, we just observe here. So for injectiveness, what you observe? Say let x comma y belongs to n plus the domain. I'm taking domain n plus be such that fx equals to fy. Now, fx equals to fy, that implies fx means 2x, fy means 2y, that implies x equals to y. So, what we have shown here, fx equals to fy, that implies x equals to y. And since x is arbitrary, so that means fx equals to fy, that implies x equals to y for all xy belongs to n plus. And hence if n plus to n plus is injective, that means the different element of n maps to different elements of the codomain set n plus. Now here you will see the element 1 has no preimage, the element 3 has no preimage, 5 has any odd number in the codomain set has no preimage. So just you will take an odd number. For the second part, let 1 belongs to n plus and this is codomain. Then the element 1 belongs to n plus, that means codomain, has no preimage in the domain set n plus. Similarly, if we take 3, it has no preimage. So in that case, you just suppose, why? Since suppose if we take x belongs to n plus, the domain is a preimage of 1 belongs to n plus, that means codomain. So what will happen then? F of x, that will be 1. That means 2x will be 1. That means x will be half. And that is does not belongs to n plus, because n plus is the set of all positive numbers, which is a contradiction. So that means 1 in the codomain set, that element has no preimage. Similarly 3, 5 in the codomain set has no preimage. So if we take any odd positive integer in the codomain set, if you take any odd positive integer, so that means 1 or 3 or 5 or 7 ... it has no preimage. And thus we can conclude if n plus to n plus, that map is not surjective. So what we proved here, if n plus to n plus is injective but not surjective. Now we'll prove next important problem that has been asked in Calcutta University Honours Examination. So CH Calcutta Honours 2001. What is the question paper? The question is every surjective mapping if n plus to n plus an injective mapping, justify. What is n plus? Where n plus is equal to set of all positive integers. So what we will do here, what should be our answer? Our answer is no. Every surjective mapping if n plus to n plus may not be injective mapping. So that means there exists a surjective mapping if n plus to n plus which is not injective. So now we need the justification, how to justify it. So as for example, we consider a map from n plus to n plus. We consider a mapping if n plus to n plus by f of n, this is equals to 1, if n equals to 1 comma 2, and n minus 1 if or otherwise. So here you will check, first you will check this is surjective map, and then you will check it is not injective. So we see that f of 1 equals to f of 2 by the definition of mapping, both are 1, but 1 is not equals to 2. So we conclude if here n plus to n plus is not injective. But you just see the map n plus to n plus, 1 goes to 1 and 2 is also goes to 1. That's it is not injective. But 3, that goes to 3 minus 1. So that means 2. 4 goes to 4 minus 1, 3. 5 goes to 5 minus 1, 4. So just you continue this process, you will see this map is surjective easily. Okay. So how will prove if it's surjective? So our claim is if n plus to n plus is surjective. So first take 1 belongs to n plus, that means codomain. Okay. Then 1 must have a preimage, this is 1 and 2 both. Then it is clear f of 1 equals to 1, in fact f of 2 equals to 1 has a preimage. Now we'll take n belongs to n plus, and this is basically codomain, and n is greater than equals to 2. Then this is our observation, f of n plus 1, that will be n plus 1 minus 1. What I said, n greater than equals to 2. So f of n plus 1, that will be greater than equals to 3. Since n greater than equals to 2, that implies n plus 1 greater than equals to 3. So by the definition of mapping, we can write this will be n. So that means n plus 1, this belongs to n plus, this is domain, is a preimage of n, and n greater than equals to 2 belongs to n plus, this is codomain. Therefore every element in the codomain set n plus must have a preimage in the domain set n plus, and hence if n plus to n plus, this map is surjective map. So what I proved? We proved F is surjective but not injective. Okay, and this is basically 3 marks question paper. Now we come to next important problem. The problem has been asked in CU Calcutta Honors 2003. A function if z star to z is defined by f of n equals to n by 2 minus n plus 1 by 2 if n is an even integer, in that case even integer, and here n is odd, that means otherwise. The question is f injective and surjective? F is injective and surjective. What is z plus? Where z star, so that means set of all non-negative integers. This is basically the set of all non-negative integers. So this is given. So now we need to check if it is injective or surjective or not. So this is basically 3 marks question. So now we will solve it. So what is exactly given? Z star to Z is defined by f of n equals to n by 2 if n is even integer. Otherwise, when n is odd, that will be minus n plus 1 by 2. So this is basically otherwise. So that means f is odd integer. First we will check if is injective or not, and next we will check if is surjective or not. So first we try to visualize this map. So this is basically Z star, set of all non-negative integers. So that means star from 0, 1, 2, 3, 4, 5, 6, 7 and so on. And the codomain is Z. So that means here 0, 1, 2, 3, 4, so on. Minus 1, minus 2, minus 3, minus 4. So first we will start from 0. 0 is an even integer because it is divisible by 2. So the map of 0 is 0 by 2. So that means 0. Next I will start 1. 1 is odd integer. If you put 1 here, so minus 1 plus 1 by 2 it will be 0 by 2. So 1 is again goes to 0. So that means that says us 0 and 1 are not equal by image are same. That means it is not injective. Now you go to the 2. 2 is even integer. So the map of 2 is 1. Now 3 is odd integer. So minus 3 plus 1 by 2. So it will be minus 1. So 3 goes to minus 1. 4 is even integer. So 4 goes to 2. 5 is odd integer. So minus 5 plus 1, that means minus 2. So this is exactly our map. So first we seen that 0 and 1 goes to the same point. So we see that f of 0, this is 0 by 2, 0. And f of 1, this will be minus 1 plus 1 by 2 because 1 is not even. It follows this, the second rule. So that will be 0 by 2, again 0. So therefore f of 0 equals to f of 1, but 0 not equals to 1. So that's what we conclude. We conclude if z star to z is not injective. Now our claim is f is surjective or not. How we will show f is surjective? So now it is our claim, or we have to prove that if z star to z is because just your observation is for each element in the codomain set it must have a preimage. So for 1, 2, 3, 4, for 1 the preimage is 2, for 2 the preimage is 4, for 3 the preimage will be 6, but for -1 the preimage is 3. So here the odd positive integer is the preimage of the odd of the negative integers, and for positive integers in the codomain set the preimage is the even integer in the domain set. So it is surjective. That we have to prove. It is surjective. We have to prove that if z star to z is surjective. So this is your z star, and here the z. We have taken an element n belongs to z. So let n belongs to z, and this is our codomain. Then our case 1, then we have to produce two cases. So here case 1, n may be even, n is positive integer or negative integer in that case. So m is, what we will do now? So okay, so that n maybe belongs to z plus. Okay, we are not taking any kind of segregation here. So let n belongs to z, and we choose okay, we'll take say m belongs to z. M belongs to z. So we choose n equals to 2m if m is positive or non-negative, that means greater than or equals to 0. And we choose n equals to 1 minus 2m otherwise. That means if m less than 0. So then if m is greater than or equals to 0, in that case f of n, that will be f of 2m, because in that case n we considered here 2m. So this will be 2m by 2, because 2m is even integer. Since 2m is even integer, so according to the definition, so this will be m. So n, that is 2m, will be the preimage. And if m less than 0, on that case f of n, that means f of 1 minus 2m, that will be minus of 1 minus 2m plus 1 by 2, and it will be m. So in these cases, what we have seen, we have basically get the preimage of m belongs to z. Since m is arbitrary, so every element of, so therefore every element of z, that means codomain, must have a preimage in the domain set. So actually there is a two possibility. We have taken m. If m greater than or equals to 0, then what we have seen, we have of 2m, that will be m. And if m less than 0, we have seen 1 minus 2m, that will be m. In the both cases, the element m in the codomain set has a p-image. In the domain set Z star. So thus we prove that thus if Z star to Z is surjective. Now we will continue the next important question. The question is asked in Calcutta University in the year of 2006. What is the question paper? The question is asked, let A belongs to R minus half and B equals to R minus half, where R is basically set of all real numbers. And let F is a mapping from A to B be defined by f of x equals to x minus 3 by 2x plus 1 for all x belongs to A. Then the question is, does f inverse exist? Justify your answer. Justify your answer. So now we'll go to the solution. So what is A? A is basically R minus of minus half, and B is basically R minus half, and the function f A to B is defined by f of x equals to x minus 3 by 2x plus 1 for all x belongs to A. So this is basically for 3 marks question paper. So we'll show that this map is bijective, and then we can conclude the f inverse exists. But question is if inverse exists or not. So this is your A, and A is basically R minus of minus half, and this is your B. B is basically R minus half, and what is given, the x goes to x minus 3 by 2x plus 1. This is your map, and we need to find if inverse exists or not. So let us take, let y is an element here. So let y belongs to B, and we consider and we take, if it exists, if f inverse exists, so every element must have a pre-image here. So we take y equals to fx for x belongs to A. Thus, what we can say, thus x is here belongs to A, so x not equals to minus half, and y is belongs to B, so y must be not equals to half. And choose, and what will be y? Y will be x minus 3 by 2x plus 1 because of this. Okay. So in that case, what we can write, 2x plus 1 into y equals to x minus 3, and you can write here x equals to the function of y, 3 plus y by 1 minus 2y, because we can, this is valid as since y not equals to half. Okay, so therefore for all y belongs to B, there exists x. X means 3 plus y by 1 minus 2y, such that f of y equals to, such that f of x equals to y. And so y equals to f inverse x. Okay, or you can write therefore f inverse exists, and what will be the f inverse? So f inverse y, that will be x. X means 3 plus y by 1 minus 2y. Since y equals to f inverse x and x equals to 3 plus y by 1 minus 2y. So thus, therefore, f inverse exists, and f inverse, the set is r minus half to r minus minus half is defined by f inverse of x equals to 3 plus x by 1 minus 2x for all x belongs to B. B means r minus half. Thank you so much. The next class we will solve more problems which has been given as a previous year question paper in Calcutta University.